I wanted to see if I could create a completely AI generated horror puzzle game that's different every time you play it, with the graphics, the puzzles, the riddles, the enemies, the music, and the narration all completely AI generated and unique every time you play it.
As you examine the faded portraits, you notice their unsettling gaze follows your every move.
And the results were pretty crazy. I literally had to change the prompts to make it less horrible. The best part is this project is super simple in Python, less than 300 lines of code, and it can teach you about asynchronous programming, prompt engineering, and working with APIs. So let me show you the finished product. I give it the name Random Realms. And basically it's like one of those old school choose your own adventure text games where you get a prompt about the setting and then you get 3 options of where to go. And now depending on the actions you choose, you might lead somewhere that will give you a clue, and that clue could be used later in a puzzle or riddle to solve it. You could also get closer to danger and get confronted by an enemy. There's also this sense of dread of someone following you and watching you the whole time, which I think is really cool.
Ahead looms a forgotten manor, its dark windows staring like empty eyes. You feel the weight of unseen gazes as you approach.
It has some pretty cool features. For example, if the setting describes taking a grandfather clock or something, the music generated will include sounds of a grandfather clock. Or let's say you're in an intense scene where you're close to an enemy and you can feel your own heartbeat pumping. That will be part of the music. Okay, so how does this work? We're calling it an LLM, and we're asking it to give us a description of the current level or setting, 3 actions that we can take, and then a more detailed description that's more tailored to generating music for the current setting. Now the LLM will provide us this in JSON format, so we can easily interpret it in Python. And with the description, we can generate the graphics, which we use an image-based model for this. And for this, we're using Recraft V3, which you can find on Replicate. We're also using the music description to generate the music, also from a model found on Replicate. And finally, we're calling the 11 Labs API to generate a British voice narration for the current setting. So from the point we get the JSON, we're doing the image generation, the voice generation, and the music asynchronously. Let me go through the code and show you what I mean. All right, so this is a super simple project, but I feel like it can teach you so much about AI engineering, prompt engineering, async, and all that. So I highly recommend giving it a try, implementing it from scratch by yourself. The code is available on GitHub. If you'd like, I can do more of a deep dive tutorial on this, like I did with my previous project, CondoGPT. That got me my first AI engineering job. So basically, it's a very simple Flask application that calls different LLMs and spits that out to an HTML file. So first of all, we initialize an OpenAI client, and now here we're actually using OpenRouter, which is a great way of calling LLM models because you can test different models and change them out without much code rewriting. We're also initializing an 11 Labs client for the voice generation. And then here's just a basic home view with Flask. So we return the home templates. And our home template is nothing crazy. We have our styling here. We have a full screen image, a text container, and the actions container. So actions are the 3 options we're presented with that we can use to progress through the game. Now, as we start the game or we press one of the action buttons, we're actually going to call the generate story endpoints. This is the initial prompt, which kind of just tells the LLM, look, we're playing a game here, generate actions, generate the setting, generate the music description, and provide it to us in JSON format. And here's some other game mechanics that I'm not really going to go through, but I was initially making this into a horror game, and then I decided, you know what, some of these images are just a little bit too unsettling for me. I didn't capture all of them, but this is one of the milder ones, so you can probably imagine how crazy it got. Because of that, I created this thing called nightmare mode. So you can enable this and it will kind of generate a lot more unsettling stories and images for you. So have fun playing around with that. I can confidently say I've served my time. But the important thing to note here is we're strictly enforcing a rule that the output format should be in JSON. So that way it's very easy for us to interpret it in Python. So basically we have the prompt, we call the LLM, and then we get the starting point of the story. Now, if this is not the first time this endpoint is being called, we have a conversation history because a lot of LLM APIs, they don't have a conversation history built in. So what you have to do is you have to create your own huge string with all the previous history in it every time you call it. That's really the only way that LLM APIs, at least most of them, can remember what you did last time. So it's a bit of a hack, but I haven't found a better way to do this yet. So from the description, we generate an image with the replicate API. We also generate the music in the same fashion, and we generate the voice using the 11 Labs client. And all of these we need to send over to the front end. Now, how do you send over files to the front end? Well, you turn them into base64. Base64 is like a string representation of files. So you can have a string that if you parse it using base64, it will give you the image. And same with music and audio too. And then we're calling all these three functions asynchronously. So we call each coroutine one by one. And then we call all these three coroutines asynchronously, which means, no, they're not happening in parallel, but generate image happens. And then as we wait for the network request to return, we can call the next routine. And then while we're waiting for that, we can also call the generate voice. So basically one API request is not clogging up the entire system. And after that, we literally just send it to the front end. Now, since this is a web app, most browsers, they don't allow audio autoplay. So we kind of need the user to click a button to make sure that the audio plays. So every time we're progressing to the next level, we show a continue button. And once you click that, we can actually play the audio. And that's when we load the image, we load the audio, the background music, the voice, and we start playing the audio. And we keep a conversation history on the front end as well. We have a nice little typewriter function that just gives it the atmospheric element. When we're ready to go to the next level, we have the conversation history, and we're going to send the entire conversation history to the API again. And that's how it works. Super simple code, I know. So as you can see, not a lot of code, but still pretty damn cool. I've been up very late playing this game and just seeing where it takes me. And it's quite interesting to see the imagination of LLMs. They can be quite creative, but also not in a sense. You'll notice certain patterns. Like even if you're starting different games, even in isolated session, different games, they'll share a lot of the same elements and descriptions. So it's quite interesting how the LLMs can seem creative at first glance, but if you prompt it enough times, the contents of the prompts will kind of like blend together and you'll start to see patterns. So that's the project. I'm putting it up on GitHub and I have some issues there that you can solve if you'd like to start building your AI engineering portfolio. One big caveat is the game is quite slow at the current stage with the models I've chosen. I have found different ways around this, choosing different models, kind of disabling the narration part of it. There's all different hacks. I'm actually making that into an issue by itself. Again, this will also be an issue on GitHub, and I welcome any attempts to improve on the game. If you enjoyed this video where I went through the code in an AI engineering project, you want to learn more, you might enjoy this video where I go through the code of an AI hedge fund in Python, which I think is like the best beginner AI engineering project I've ever seen. So check it out, let me know what you think. Thank you so much for watching, and I'll see you later.